Welcome to G Fun Facts Online. The era of the International Space Station, humanity's magnificent outpost in the cosmos for over 2 decades, is coming to an end. But this isn't a finale. It's the beginning of a revolutionary new chapter. The ISS is set to be deorbited in 2030, but its retirement is paving the way for something even more exciting: a vibrant ecosystem of commercially owned and operated space stations. We're moving from a single, government-funded giant to a bustling neighborhood of homes in orbit. Today, we're going to explore this new dawn, looking at the pioneering companies building our future in space, the mind-blowing technologies making it possible, and what it all means for the future of humanity among the stars. The International Space Station, or ISS, is arguably one of the most successful international collaborations in history. A consortium of 5 space agencies from the US, Russia, Europe, Japan, and Canada built and have operated this engineering marvel, which has been continuously inhabited since November 2000. It has been a premier laboratory, a technology testbed, and a home to over 250 astronauts. But the station is aging. Its hardware and maintenance costs are rising, leading to the decision for a planned retirement in 2030. This created a sense of urgency. We cannot afford a gap in our ability to live and work in low Earth orbit, or LEO. In response, NASA has launched a bold new strategy: the Commercial LEO Destinations Program, or CLD. This program represents a fundamental shift. Instead of owning and operating its own stations, NASA will become a customer, buying services from private companies. This public-private partnership is designed to slash costs, spark innovation, and create a competitive marketplace in LEO. NASA has already awarded initial funding of over $400 million to companies like Blue Origin, NanoRacks, and Northrop Grumman to develop their station designs. This frees up NASA to focus its own resources on grander adventures, like the Artemis missions to the Moon and the eventual human exploration of Mars. It's a change in philosophy, moving from a government monopoly to a dynamic ecosystem where private companies take the lead. So who are these new kids on the orbital block? Let's take a look at the frontrunners. First up is Axiom Space, which is taking a very pragmatic approach. Instead of launching a brand new free-flying station from scratch, Axiom is building its station piece by piece, initially attached to the International Space Station itself. This allows them to use the ISS's existing power and infrastructure while they assemble their modules. The plan starts with launching the first module in 2027, followed by 2 habitat modules, HAB-1 and HAB-2. These interiors, designed by the famous French architect Philippe Starck, promise a more comfortable and luxurious environment, with tufted walls and massive Earth-gazing windows. Once fully assembled, the Axiom station will nearly double the usable volume of the ISS. Then, just before the ISS is decommissioned, the entire Axiom segment will detach and become its own free-flying, independent commercial space station. This step-by-step plan reduces risk and allows Axiom to build operational experience through its ongoing private astronaut missions to the ISS. Axiom's close collaboration with NASA makes it a very strong contender to be one of the first commercial outposts in orbit. Next, we have Orbital Reef, envisioned as a mixed-use business park in space. This is a massive collaboration between Jeff Bezos' Blue Origin and Sierra Space, with giants like Boeing also on board. Their goal is to create a vibrant hub for commerce, research, and tourism. The design is modular and can support up to 10 people in a volume nearly the size of the entire ISS. A key feature is Sierra Space's Life modules, large integrated flexible environments. These are inflatable habitats that launch in a compact form and then expand in space to create huge open-plan areas. Orbital Reef is designed to be an open platform, offering turnkey services to a wide range of customers, from space agencies to private companies and, of course, space tourists. They even plan to have a single-person spacecraft for external excursions. Orbital Reef represents a bold vision for a diverse business ecosystem in space, potentially becoming a key driver of the entire LEO economy. Then there's Starlab, a joint venture between Voyager Space and the European aerospace giant Airbus. Starlab is taking a completely different approach with its single-launch space station. Unlike the modular designs of Axiom and Orbital Reef, Starlab is designed to be launched as one single, complete unit. The goal is to be fully operational within weeks of reaching orbit. This no-assembly-required strategy could give it a huge advantage in speed and cost. The station will consist of a large metallic habitat module and a service module, capable of hosting a crew of 4. The interior is being designed in collaboration with Hilton Worldwide, aiming for comfort and functionality. Originally, the design included an inflatable module, but it was later switched to a metallic structure when Airbus joined the project. Starlab is targeting a launch no earlier than 2028 aboard SpaceX's Starship, the only rocket powerful enough to carry it. By offering a rapidly deployable science park, Starlab aims to provide a seamless transition for researchers as the ISS era ends. Finally, there's the ambitious newcomer, VAST. Founded by billionaire Jed McCaleb, VAST has burst onto the scene with aggressive plans. They are starting with a smaller station called Haven 1, scheduled to launch as early as May 2026. This mini-station will host a crew of 4 and serve as a crucial test bed for VAST's technology. But the company's long-term goal is much bigger. They plan to build HAVEN2, a large modular station designed to succeed the ISS, with a projected completion date of 2032. But the most exciting part of VAST's vision is its plan to develop an artificial gravity space station. This would be a complete game-changer for long-duration spaceflight. Living in microgravity causes muscle atrophy, bone density loss, and vision problems. Artificial gravity, likely created by rotating the station, would mitigate these health effects. By tackling this incredibly challenging but vital technology, VAST is positioning itself as a leader in the quest for a sustainable human presence in space. While the commercial sector is focused on low Earth orbit, national agencies are looking even further. NASA's Artemis program includes a crucial component called the Lunar Gateway. This will be a small space station, not orbiting Earth, but orbiting the Moon. It's another international collaboration, involving NASA, Europe, Japan, and Canada. The Gateway will serve as a multi-purpose outpost, a communication hub, a science lab, and a staging point for crewed missions to the lunar surface. It's also a critical proving ground for the technologies we'll need to eventually go to Mars. The first 2 modules are scheduled to launch together in 2027. At the same time, China has independently developed its own impressive outpost, the Tiangong Space Station, meaning Heavenly Palace. This modular station has been permanently crewed since 2021 and could potentially outlive the ISS. Tiangong is a testament to China's growing space prowess and is a platform for over 1,000 planned science experiments. China has also expressed a strong desire for Tiangong to be a hub for international cooperation, inviting other countries to send astronauts and conduct research. This could make Tiangong a key platform for global science in the post-ISS era. The rise of these new stations isn't just about building new habitats. It's about creating a whole new economy in orbit. One of the most anticipated sectors is space tourism. For decades, going to space was a dream for a select few. Companies like Axiom, Orbital Reef, and Starlab plan to make that dream a reality for a wider audience. These orbital vacations, offering breathtaking views of Earth and the experience of weightlessness, could become a multi-billion-dollar industry by the early 2030s. While the initial ticket price will be in the tens of millions, costs are expected to fall over time with more competition and cheaper launch options. Beyond tourism, there's in-space manufacturing. The microgravity environment is perfect for creating things that are difficult or impossible to make on Earth, like more perfect crystals for pharmaceuticals, or more uniform alloys for advanced materials. High-quality fiber optics produced in space could revolutionize telecommunications. The ISS is already served as a testbed for this, and the new commercial stations will have dedicated facilities to turn this potential into a real industry. The factory of the future might very well be floating 400 kilometers above our heads. Of course, as we push this new frontier, we must also confront the challenges. The human body is not built for space. We need to solve the health problems caused by microgravity and radiation exposure. This is where technologies like closed-loop life support systems, which recycle air and water like a mini-Earth, and artificial gravity become so crucial. There are also ethical questions. Will space become a playground only for the wealthy? How do we prevent polluting orbit with even more space debris? And how do we manage the extraction of resources from the Moon or asteroids without conflict? The Outer Space Treaty of 1967 was written for a different era, and our laws need to catch up to this new age of commercial spaceflight. We are at a pivotal moment. We are transitioning from an era of government-led exploration to a future where a diverse ecosystem of private companies creates a multitude of homes among the stars. The competition between Axiom, Orbital Reef, Starlab, and VAST is a sign of a healthy, dynamic market. This shift is about more than just replacing old hardware. It's about fundamentally changing our relationship with space, creating a new economy, and forging the technologies we need to venture to the Moon, Mars, and beyond. The path ahead is challenging, but the potential is immense. The dawn of this new era is upon us, and the future of humanity in space has never looked brighter. Thanks for tuning in to G Fun Facts Online.